Now in this video, I want to show you how we can collect simultaneous EDS data as well as save the patterns for subsequent analysis with things like NPAR or OIM matrix dictionary or spherical indexing. So I'm going to go ahead and collect a new area of interest. It's the same area, but it will create a new node in the project tree. And simultaneous data can just be acquired by clicking on simultaneous EDS. Saved patterns, you have to be in the details mode here. Click on Save Patterns. You have two different options, the UP1 or UP2 file format. UP1 is saving 8-bit images into the file. UP2 is saving 16-bit images. I like to use the UP2 just to have it all available, so I don't have to think about it essentially. But both are viable. The higher, the more you're using the dynamic range, the more you should use the UP2. So this is the default and the safe value. When I have this ready, I'm going to hit collect, and it's going to prompt me to say what elements do I want to use. If I've used the EDS detector, these will be pre-selected. When we're collecting simultaneous data, it is saving the full spectral information, but these are the EDS ROIs that are going to be displayed in OIM analysis and in Apex during collection. So this is a nickel alloy, so I have nickel, iron, chromium. There might be some sulfur, oxygen, silicon, maybe some moly. And I'm going to just hit OK. It's going to save the patterns. Now it's just going to do a regular collection. It's just a coarse data scan. It's quick. You can see if I look on EDS now, it's showing me all the different EDS maps. It's going to be a pretty boring EDS sample, but it gives the idea of what we're trying to show. And we can look at the data in OIM analysis. But the data collection is pretty much the same. When it finishes, it's going to give me this information. It saves all this data. If I look in a project, if I look at this folder, I'm on the E drive here. I'm in EDX Apex. You can see that we're saving data, the H5 file, but now it has also saved a UP2 file associated with that particular area. This is important if you ever want to move the data off the microscope. If you want to do analysis with patterns, you take this UP2 file with the H5 file. You can see that it gets to be pretty large by saving patterns. And so it can be a little bit more time to move those back and forth. That's some reasons why people will sometimes use a UP1 file. Now if I open, first let me show on the project tree, this node now has listed EBSD and EDS data. I could come and do reprocessing of the EDS data like this was an EDS data set in Apex, or if I double click on this mode, this will open it in OIM analysis. You can see here it shows me my EDS elements that I selected. I can click on this icon here to show me the quick maps. Again, this is just an alloy sheet, so I don't expect a lot of information. You'll also see I really haven't optimized for the count rate. If I wanted more EDS statistics, I would either insert my EDS detector further, or I would turn up the beam current to be able to optimize my EDS counts. The other thing I want to show is down here, it says that the saved patterns are available. So if I wanted to see these, I can bring like an image quality map up, go to my Flexiview and say add pattern flyby. And then I'll see the pattern at each point. I can do a static pattern as well and shift click to show a pattern here or here. The number changes, so if I wanted to add another static, this is why it's called Flexiview, is I can flexibly arrange what I'm going to see, but I can see the saved patterns in different parts of the microstructure. And I can also go up here to my re-indexing. This is where I can come click on a point and it would load the pattern to do things like NPAR. So it's pretty easy with these buttons here to save the patterns, to save simultaneous EDS data, to extend beyond the traditional EBSD data collection.